The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome, ladies and gentlemen. I'm DrAvitech, and we're going to be solving this very problem. So we're asked to, let me read the equation first. The voltage from a square wave generator is of the form shown below, obviously, and has period of 8 milliseconds. Find the Fourier series of the function. Now, there's really no need for you to sketch that function, so let's not waste our time doing so. Let us start by finding the first coefficient, which is A0. So A0 is equal to 1 over L integral from minus L to L of f of, okay, since this is V, this will then become V of t dt. That's what it's going to be. Now, please take note, if you're looking at your function, the period is 8, right? So your L is always half the period. L is always half the period. So that means L is going to be 4. So L is equal to 4. L is equal to 4. So this will become 1 over 4 integral from minus 4 to 4, then V of t dt. So that is what it's going to be. Another thing you need to know is there is no function value, there's no single value from minus 4 to 4. There's no minus 4 to 4. Instead, they broke it down, minus 4 to 0, and then 0 to 4. So we're going to break our own down too. We're going to say this is 1 over 4, then integral from minus 4 to 0, V of t dt, plus the integral from 0 to 4, V of t dt. So this is what we're going to have. And let's put in our values. So this is 1 over 4. Then we have the integral from minus 4 to 0. Now from minus 4 to 0, what is V of t? V of t is equal to 0 at this interval. So this will be 0 dt. Plus integral from 0 to 4. From 0 to 4, what is the value? It was 10. So this will be 10 dt. Now if you notice, the integral of 0 is still 0. So everything here will just give us 0. Now in case of the next coefficient, when I start finding the next coefficient, I won't be putting this one because it will always give me 0. So this will be 1 over 4. The only thing remaining will be this. Now if you integrate 10, you'll be getting 10x. And this is from 0 to 4. So right now, the 10 can come outside. It's a constant, so the 10 can come outside. So this will be 10 over 4. It can come outside, so that's 10 over 4. What will be left is the x from 0 to 4. So this will become, if you simplify this, this will give you 5 over 2. So that's 5 over 2 into, now this is x. Put in your upper limit, you get 4. Minus, put in your lower limit, you get 0. So this will become 5 over 2 times 4. 5 times 4 is 20. 20 over 2 is 10. So that's what that's going to give to you. It's 10. A sub n is equal 1 over L, integral from minus L to L, V of t cos n pi t over L dt. So that's what we have. Now the next thing is for us to put what our L is. Remember that L is half the period. The period is 8, so half of 8 is 4. So L is equal to 4. So this will be 1 over 4, integral from minus 4 to 4, V of t cos n pi t over 4 dt. That's what we have. Now remember I said the integral is from minus 4 to 4, but we have two values. So it was broken down into two parts. So it's broken down into minus 4 to 0 and 0 to 4. But I'll be using only the 0 to 4 because the answer I have here is 10. But when it's minus 4 to 0, that's 0. So it's not useful. So I'm going to throw it away. So this will be 1 over 4 integral from, I'm only going to be using 0 to 4. Then V of t is 10 cos n pi t over 4 dt. So this is what I have. And the 10 again is a constant, so bring it out. So bring it out. So this will be 10 over 4, integral from 0 to 4, cos n pi t over 4 dt. Now this will become 10 over 4 will give us 5 over 2. So this is 5 over 2. Now if you integrate cos, you're going to have sine. So this is sine n pi t over 4 divided by, now remember that you must always differentiate the angle. So if you differentiate this angle with respect to t, you will get n pi over 4. You will get n pi over 4. Now this n pi over 4, you'll be dividing by it. So that's n pi all over 4. It's a standard way of integrating trigonometric function. You must divide by the derivative. It's a must. Then you put your limit 0 to 4. Why do I feel that this will be giving me 0? That's what I kind of feel. I think it's going to give us 0. So let's see. First of all, this part is a constant, right? This part is a constant. So let me bring it out. So this is 5 over 2. Then times 1 over, this part is coming out. So that's n pi all over 4. And then we have sine n pi t all over 4 from 0 to 4. All right, now this is 5 over 2. This guy you see here, since this is n pi over 4, the over 4 will come to the top. So this is 4 over n pi. Just like you take it, the reciprocal of a fraction. So the reciprocal of a fraction, the 4 will go up, the n pi will remain at the down. Now this part, anywhere you see t, you put 4. So let's do that slowly so you conveniently see how this will give us 0. So this will be sine n pi 4 over 4, because t is now 4, minus sine n pi 0 over 4. Okay. Now, this will be giving me 10 over nt. 5 times 4 is 20. 20 over this 2 is 10. Now, 4 we cancel out 4 here. So this is sine n pi. Minus, this is 0. 0 over 4 is still 0. So this is sine 0. Now, remember that when we're doing some other functions earlier on, sine n pi is 0. Also, sine 0 is also 0. So this is 0. This is also 0. So if these two are 0, that means everything here will just be 0. So a sub n, I don't think I need to write it here, so I'll use this space to find b sub n. So a sub n is equal to 0. I'm going to keep that. So that's a sub n. Now for b sub n, so we have 1 over L, integral from minus L to L. This is v, so I'll say v of t sine n pi t over L dt. Now we know L is 4. So let's put 4. So this is 1 over 4, integral from minus 4 to 4, v of t sine n pi t over 4 dt. Now again, the only function we're going to be picking will be this one, because this is 10, while this is 0. So 0 is nothing. We're going to use only this one. Now the integral for this one will be 0 to 4. So we'll say this is 1 over 4, integral from 0 to 4. Then v of t here was 10. So this is 10 sine n pi t over 4 dt. Okay, it's looking beautiful anyway. So this 10, you want to bring it here. You want to bring the 10 outside. So this will be 10 over 4. Then we have the integral from 0 to 4 sine n pi t over 4 dt. Okay, I want to leave the 10 over 4 like that. So that's 10 over 4. I want to leave it like that. Then open up this bracket. If you integrate sine, you will get minus cosine. You get minus cos. And then you put your angle n pi t over 4. Now when you differentiate this angle, you will have n pi over 4. So you need to divide by that n pi over 4. You need to divide by n pi over 4. And this will be from 0 to 4. That's the interval of the integration. So this is 10 over 4 times, this is a constant. So this is times minus 1 over n pi over 4. And then we have cosine of n pi t all over 4 from 0 to 4. Okay, now at this point, let's simplify. So this is 10 over 4 times, if you take the reciprocal of something, of a fraction, the 4 will go up. So this is minus 4 over n pi. And then this is cosine of n pi, t will now become 4 over 4 minus cos n pi 0 over 4. So I evaluated the limits. So I'm putting the values inside to evaluate the limits. Now, this will cancel out this, which I believe we knew right from time. So 4 will cancel out 4. So this is minus 10 over n pi. Now, 4 will cancel out 4 here. So this is cos n pi minus n pi 0 is 0. 0 over 4 is still 0. So this is cos 0. Now this will become minus 10 over n pi. Now cos n pi has a special value. That special value is minus 1 to the power of n. That's the special value. And then minus cos 0 is 1. Special value 2. Now this bracket here, if you've been following me, this bracket has a particular behavior. So sometimes it's 0, sometimes it might give you minus 2. So I'm going to say when n is odd, let's see how that guy will behave when n is odd. So only this bracket when n is odd. We have minus 1. Let's put this n here as 1 because 1 is an odd number. So this is minus 1 to the power of 1 is still minus 1. Then don't forget that there's a minus 1 here. Now minus 1 is minus 2. So when n is odd, this value of this will be minus 2. That means our b sub n will become minus 10 over n pi times this bracket here is minus 2. So that means b sub n will be 20 over n pi. So again, this is when n is odd. And let's see, when n is even, let's see what's going to happen when n is even. So when n is even, so we're going to have minus 1. We're talking about the brackets, remember? So we have minus 1 squared minus 1. So this is minus 1 squared. When you square a number that is negative, you're going to get positive. So this is plus 1 minus 1. Now what's plus 1 minus 1? That's 0. So this means our b sub n, which is minus 10 over n pi, times this bracket, the bracket is now 0. So this means that b sub n is equal to 0 when n is even. Now I want to wipe the board, so I'm going to keep my answers here. So I'm going to say, let me see. Okay, my a sub n is 0. B sub n answer, I don't need to wipe, I'll just clean this part. Then this is equal to 10. Yeah. So let's get the Fourier series of that very function. Now f of x will equal to a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos n pi. Oh, this is in terms of t. So I'm going to just write v of t. So v of t is equal to this n pi t over L plus the sum from n equal to 1 to infinity of b sub n sine n pi t over L. Now we know that L is 4. We know that L is 4. So v of t will become a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos n pi t over 4 plus the sum from n equal to 1 to infinity of b sub n sine n pi t over 4. Now, this part will be 0 because we had 0 here. So a sub n is 0, so it's gone. So the only two remaining guys is this and this. Now, a naught is 10. So this will be 10 over 2 plus the sum from n equal to 1 to infinity. Now, b sub n is the only useful value is this one. This is the only useful value. So we're going to be having 20 over n pi. And then sine n pi t over 4 But remember that this is always odd. It's always odd. So this is odd. Now 10 over 2 is 5. So this will be 5 plus, what is the constant here? 20 over pi is a constant. So bring it out. This will be 20 over pi, where the sum from n equal to 1 to infinity. What will be left is 1 over pi will be left, because the 20 is out from the numerator. So remember that this can be 20 times 1. So this is 1 over n, sorry, not 1 over pi. 1 over n sine n pi t all over 4. Okay. Now at this part, this should be my answer. But if I should say, let me leave my answer like this, it might not really be looking nice. So I've always been doing something, if you remember. Whenever I have odd, I would say replace n with 2n minus 1. Whenever that happens. So this will be 5 plus 20 over pi. Then with the sum from n equal to 1 to infinity, I will replace all my n with 2n minus 1. So this is 1 over 2n minus 1 sine 2n minus 1 pi t over 4. So this time around, every single thing here will just be odd because of this part is even. When it's even, it's 0. So if I should leave it here, I might go and forget that I am only picking the odd values. But if you are someone who does not forget, please use this stop part. But if your question says in terms of n, leave your answer like this. Now let us write out some expansion. Let's bring out some things from the function. So when bringing out some things, I prefer to use this one at the top. I prefer to use this one. V of t, v of t, v of t. So let's expand. I want to use this one at the top. I prefer using this one. So v of t is equal 5 plus 20 over pi. Now this sum, let me start. When n is 1, this will be sine pi t over 4. Look at it this way. 1 over 1 sine 1 pi t over 4. Now you know 1 over 1 is 1. 1 times sine is still sine. So 1 times pi t is still pi t over 4. That will be the answer for that one. Next will be when n is 3. So this will be 1 over 3 sine 3 pi t over 4. Next will be 5. So this is 1 over 5 sine 5 pi t over 4. Next will be 7. So this is 1 over 7 sine 7 pi t over 4. And just like that. So you might want to put a bracket here. So this would then be the answer to that very equation. And with this, we're done with solving this very problem. I'm going to see you in the next one. Bye.